All right, so that's just the usual reminder. We'll come back to that at the end. I just want to very quickly set the frame. Streaming is such a very kind of commonly used term these days, so I just wanted to quickly set your sort of mind around what we're referring to here. For many of you, this will likely be totally obvious. So just in case, so when we talk about data at rest in a traditional way, one simple picture is it's just cars in a parking lot. And if you want to ask questions like, how many red cars are there in the parking lot? It's like asking a database question. We scan the parking lot, maybe with an index, and we count the cars. Right? With data in motion, cars keep flying by on a freeway. Diverting them to a parking lot in order to count them would be the approach of capturing streaming data into some archive and then running batch jobs over them. What we want to do, talk about here, is processing data in motion while it's flying through the system. Okay, so it's all about, for example, counting the red cars as they drive by. And the question, how many red cars drove by, doesn't even have an answer unless you also say, within the last 10 minutes. Right? Because the question, how many cars drove by, for an infinite sequence of cars will actually never return. Okay, so before we dive into how the various things are built, I wanted to do a first little demo. We have worked from really our private preview stage on with a Swedish medical device manufacturer, Aerocrine, and their claim to fame is a device, looks a little bit, we sometimes jokingly say it looks like a breathalyzer. It actually is a breathalyzer, but it doesn't look for alcohol. It looks for nitric oxide. And it turns out, if you do it exactly right, it is an excellent early detector for a kind of a pending asthma attack. So as an asthmatic, you can actually use this device to find just the right time to take steroids or to avoid taking steroids, which have their own problems. So that's what they do, and they wanted to move beyond building their devices, and in particular, they wanted to move to a point where the devices can be run in practices or even in homes where people have possibly no training for proper use. So let's just look at how this device acts.
Sure. A patient will usually hold this mouthpiece, and the process of running an experiment is first you inhale the air and then you breathe out into the device, and the process takes approximately 20 seconds. There are some sensors inside the device, and Aerocrine wanted the hospitals who use them to be in a certain environment condition, to maintain certain environment conditions for this to work properly. Sometimes they are not, and the device calibration may go wrong. The doctors doesn't even know when they're trying it out. So now after this gets hooked up in a real-time system, they can easily alert the hospitals that, hey, this particular device needs calibration or your temperature conditions has changed. So let's see how this real-time nature will look like. I will try to run an experiment, and this particular chart shows the humidity coming from a sensor inside this device. It also tells me the temperature, and when I inhale and exhale, that creates a pressure that can also be shown in the map. Okay? Oh, I need to start an application. This device gets connected to this laptop or any PC, and using an application, it will transfer the data to the cloud.
So what we're seeing here is the pressure change. During inhale, pressure drop. During exhale, pressure rose. Now the device will take about a minute to come up with some diagnostic results. And what Aerocrine really wants to do is not just monitor one such device remotely. That may be interesting for a physician. What they really care about is monitoring all their deployed devices, today in the thousands, with ambitions to go way beyond that, centrally, so that they can look for various opportunities like reaching out for support or delivering a new biochemical sensor that is about to reach its end of life. So at this point, I think we can go back to the actual deck and step back a little bit sorry, wrong back. What we just saw is a scenario of connecting devices that historically were either not or only weakly connected to meet some sort of larger business demand. And here's a whole collection of scenarios that we have looked at with various partner companies. The two things I want to quickly drill into here are real-time fraud detection and what here is called smart grid as two different examples. The first one is actually a fairly generic thing. We have seen banks that are interested in looking at ATMs that show, for example, a strange withdrawal pattern where just before midnight and just after midnight, the maximum allowable amount is withdrawn. And they would like to use that to immediately trigger an alert. Likewise, and by the way, this isn't always fraud, but it's very commonly correlated with fraud. Then another case would be click fraud in advertising systems, various forms of fraud in online gaming systems, and so on. So there's a whole world of trying to look for anomalies that indicate fraudulent use. The smart grid case is quite different, and you actually saw it mentioned in the keynotes. The eSmart guys from Sweden talked about that this morning as well. The idea here is to go and say, by having all my devices in the field connected to the cloud, I can look for various opportunities like preventative maintenance. So in the smart grid case, I may want to go and reroute power through a different branch in the system if, for example, a correlation between load prediction and weather forecast suggests that there's a huge opportunity for an outage based on the current power transmission lines that were chosen by the system. Right, so there's a number of things you can do by stepping out of the system, looking at a lot of data, correlating it with contextual data like weather data. So with that, I would actually like to welcome Richard McCormick on stage, who is the VP of Sales and Marketing for Fujitsu America, and we'll talk about a really exciting application that you might not see coming. And it's not connected cows.
Thank you, Clemens. Thank you. Some people here probably saw Connected Cow this morning. I will put that in context with what else we got. I do have some other goodies here. Clemens, where can I put this? Put it right there. There we go. We're just fine. So we have worked with Microsoft over the last few years on a specific proof of concept around production of lettuce. I'll show you that in just a little while. This is part of a total Fujitsu solution known as Akasai. It's a one-stop shop information and communication solution in the food and agriculture area. We've been doing production management control, greenhouse work, which is where the lettuce comes from, a full remote sensing network of IoT sensors out there, and then animal husbandry. Clemens, that's where the Connected Cow story came from this morning. If you didn't hear the story in the area of animal husbandry, when the lady cow is in the mood, as they say, we can detect that through a cow pedometer hooked up to an Azure cloud and then work it out. But I think Joseph did a killer job on that this morning, so we don't need to repeat that story. He took all the glory of Connected Cow, and he left me with lettuce. So I'm here to tell you about that story. After he took the meat, I get the lettuce. But that's fine. So what did we actually do? Probably the best way to show you how the lettuce is farmed and where it comes from is to jump straight away to a little video where we actually go live into the factory, and then I'll describe it in words straight afterwards. But Clemens, if you can play the video, it's just a minute and a half long or so. That should be just great.
Is that actually on the audio?
No.
All right, so we probably should have rehearsed that aspect. You want to talk to it? Or?
I can talk to it.
Yeah, sorry for that.
So what the commentary is saying is we've connected up the factory to a set of sensors, and here are the technicians working on that. Factories in the Fukushima prefecture of Japan. It's a former semiconductor factory, a Fujitsu semiconductor factory. It has a clean room, and we've taken that clean room environment, changed it from producing chips to producing lettuce. And you may say, why would an electronics company like Fujitsu wish to be producing lettuce? The reason is that people with kidney issues need low potassium foods to help themselves eat. Low potassium foods can be gained by boiling the food. So if you're used to having boiled Brussels sprouts, boiled potatoes, and things like that, you'll be just fine on a low potassium diet. If you want something crunchy, if you want something a bit more raw, a low potassium diet is perhaps not the way for you to go. So what we've done is we worked with a number of universities and worked out how to gain or how to manufacture, how to grow low potassium lettuce. It's more expensive than standard lettuce, of course, but if you're in an environment where you can't eat lettuce normally or other crunchy products, then this is a little bit of a health improvement for you. The application they're running on the screen, I can just hear them talking about, measures a number of different parameters. I'll tell you about that when I show you the app, because I've got it running live on a PC here. And I think it's about to end, so I can move on.
Yeah,
cool.
Actually, I don't know whether that's a good time to show the produce.
So the product itself, when it comes out, gets shipped in standard bags like this. This one was actually shipped in last Friday from Japan. Because it took quite a while to get here from Japan, the lettuce itself inside wasn't particularly good. And anyway, the FDA told me they didn't appreciate me bringing real lettuce in from Japan without a proper license. So in fact, they shipped me an empty bag this morning, and I went to my good local organic market and put American lettuce in there. Delicious American lettuce. So if anyone wants to come up and say, Richard, can I try that low potassium lettuce? No. You have to trust me. This is exactly what it looks like, but it's kind of fun to have our logo on the front. There's the lettuce there. The best part of the packaging, though, turn it around the back. Bunch of Japanese characters, of course, describing the lettuce, and then it says size M. It's like, oh, that'll never do for the American market. We need XL or maybe XXL lettuce if we're going to sell it in this market. But Clemens, it's not being produced, as I said, from a size point of view or taste point of view. That is interesting. The real key thing is, of course, the low potassium count in there. So how do we do this? Let me show you. If you go on to the next slide while I grab my little PC here, and you really caught me out by making me do the voiceover on that one. That was not very fair of you, but that's okay.
Thank you for jumping right in.
Yeah, we can do it. So let me bring up the app. So the app itself, which the technicians have in the factory, has a number of different parameters on it. It's monitoring in the factory temperature, it's monitoring humidity levels, CO2, of course, conductance, that's a salinity measure in decisiemens, the pH level, and the temperature of the broth itself. They produce the lettuce, basically hydroponics. So it has fluid growing. If you want to produce lettuce in a known and very carefully controlled environment, you can't just plant it in the ground. No matter how carefully you monitor the ground and you take care of it, things get into it. So it's produced in the clean room under the control of hydroponics with complete control of the environment. First innovation wave we did at the Akusai plant factory, as I said, in Fukushima, resulted in us producing physically the lettuce. But we had variations in production. There were variations in batches. There were variations in the time of when we could do things. And we're streaming a huge amount of data back from the tool itself. We didn't know and didn't see how we could correlate and work between those things. Hence, we called our good friends at Microsoft. And the second round actually moved the data into the Azure cloud and moved the data analysis into Power BI and Power View. So let's move on to that next slide, please, Clemens. So we're not finished there. We're moving forward. I left some of my nice Japanese translation in here. Provide foods with pleasure. That means, I can't write that on the slide. What that basically means is not just not only expanding the number of different products that are made with low potassium, that's doing improve the taste. Maybe you will want to buy my relatively expensive lettuce just for the flavor of it in your burger, but that was not the goal. The goal, of course, was quality control and optimizing the environment. It's right in Fukushima, which is in Tohoku region of Japan. That's the region that had the earthquake, if you recall, 2 years ago, Brian, something like that. So it's in that region. So we're using this effort to advance agriculture in that part of the world. And of course, we're improving our business and doing proof of concept around ICT concepts. Keep going, Clemens. If you can hit the go button, that would be just great. Here's what the factory concept looks like in terms of visualization. We've got a nice dashboard we've built at an executive level, a management level, and an operational level. What you saw on the little Fujitsu Windows tablet I just showed is like a mock-up of it. Let's jump into the actual, if you can go and play the video of the actual design itself. It looks fantastic. We just won an award at the IF Design Conference for the design itself, and we'll talk you through this one once Clemens plays it. Sorry, Clemens, I put my PC on top of your. There we go. So here's the front-end interface. In this case, it's actually an environmental monitoring interface into the tool. The Japanese language, you'll be able to understand some of the city names in a minute, but you can see us looking for trouble. When there's trouble going on in the world, the trouble information is going to come up in red. Here we can see something happening around a power facility in Japan, and I think the operator is going to zoom in just a second into this specific region of Japan, and there is the city of Chiba running at 110% of whatever the thing is it's measuring at that point. Where could that problem be? It's right there in this particular factory. So we've done a zoom in now to factory level. We've spotted what's going on inside the factory. It's on that particular production line. You've now got a monitor showing you exactly what's going wrong on that production line, and I think now it's actually going to even say there's the specific device, there's the piece of equipment which is going wrong. The interface, therefore, is built in a very beautiful way to look like that. It's going to play, it'll go, Clemens, it'll keep going. It just has a little gap for me to get breath back. Don't worry. Now, yeah, it was a good gap, wasn't it? So now we move to a different part of the demonstration, not quite so visually appealing, but here we go looking at a number of different samples. This data is live data from Fukushima, so if you look at the little gray stuff on the left and right, that's not a PowerPoint issue or even a Windows 10 problem. The guy's actually gone and rubbed out the data there because he didn't want this information going out. But what they're doing is looking at quality management here, looking at the different sample batches in the post-planting environment, i.e. the lettuce has been planted. Let's monitor as it goes along. And now we're going to actually look at 3 different environment variables. We just changed the name to be environment A, B, and C instead of saying actually what it was in terms of either salinity or pH level or temperature. Look at what's been happening at those different environmental variables over, I think this is a 6-month period in the middle of last year, and then go into correlation. This was where the benefit came of PowerView and the streaming analytics to allow us to actually correlate data. Even though I'm not a farmer, normal farmers can't really understand the difference between these different variables. So we wanted to use machine learning and use the computer side of things to actually try and help us out. So what we're doing here is choosing a date range and then drilling into some details of the correlation between the tools. And I think the guy's going to hit the Japanese button for a play in just a minute to actually then play and look for the correlation between these variables over this time period. And that he just clicked there, for those of you that can speak Japanese, was play me the time stream. And I think down the bottom of the screen, it'll now whip along and then show you the correlation between the various data factors that it's found. There he goes, pressing his button now at the very end. So in this way, we're able to drill down and find more detailed information. Jump up to my next slide, Clemens, if you can. So here's what the Azure environment, next one after that, please, Clemens. And again, there we go. Here's what the system landscape looks like. You can see we're using a full Azure environment. We've hooked up with event hubs. We've got our IoT platform on the left in the factory, coming through Azure with the different event hubs into the management dashboard, which I just showed you a little example of. We can also, of course, put the information into Office 365 if we need to as well at the same time. Keep going on to my next slide, Clemens. I'm just conscious of your time so we can get through this. So lessons learned from the whole proof of concept. Number 1, it worked. You can buy it. It's on sale now. Not this one, of course, because this came from my local organic farmer, but bags like this full of delicious lettuce if you were in Japan. It's proven to be a concept that worked. We found as we worked together from an innovation point of view, you have to choose your right partners together, Fujitsu and Microsoft working together, but you need that support of your end user customer. extremely important, we found, as we work with the end users, with the farmers in the factory. They were most interested in focusing on the apps, the IoT apps themselves. They didn't so much care about what was happening in the back end in the cloud or what was happening out there in the IT section. They were the farmers, and they wanted to learn how to use the data. That's where I think we saw the real power of the Azure analytics. Thank you, Microsoft.
Thank you, Richard.
Thank you.
Thank you, Fujitsu.
Thank you, everyone.
All right, and because it's so much fun to look at what other people do with your technology, we now have Todd van Naarden talk to us about a project that actually had quite a few partners over the time, and I think he can talk about that. Todd is an architect for the Microsoft Technology Centers, which some of you may know. They have locations in many cities and help anyone who wants to use kind of our leading, bleeding edge technologies to build solutions. And they have a number of sample solutions and demonstrators, and so it's kind of fun place to go to as well.
Thank you.
Todd.
Hi. So good afternoon. So Project Inception. It's got a cool name. Probably not as cool as the growing the lettuce thing, but we're doing some cool stuff. How many of you have been down to the Connect booth downstairs and saw the Target Cosmetics demo, right? A few of you. If you haven't, after we get done, you're going to want to go see it. All right. Inception is a project that was created sort of collaboratively between Microsoft and Target. And candidly, it was actually a larger project than even that. One of the things that I find challenging is I've been in this industry for a while, and I'm still not thrilled with how computers work. All right. Candidly, the way we interact with technology, the way we use tablets and devices, essentially they're mainframes and really small suits, all right? I want Tony Stark, okay? I want Jarvis, all right, is what I'm gunning for. I want the ability to create ambient intelligence, the ability to engage you on your terms doing what you want to do. And Target wanted to do the same thing. They wanted an experience that actually understood what the consumer or guest was doing and reacted and modified to them based on what was happening. The intent is to make it almost magical, to leverage what they already have in the form of infrastructure and to ultimately understand the user's intent. The other key thing is, while I could certainly go out and point you at some really killer MSR videos with like really cool interactions, right? And I want to build those. I only get 3 weeks, and I don't have a PhD in mathematics, all right? What's amazing is the technology that the folks in Azure Stream Analytics and Azure overall and some of the sensor technology that's coming to bear that allows pretty traditional developers to push the envelope, to really change the way people experience technology. Inception, I hope, proves that out. Go ahead. So what I'm going to demonstrate is a reference that we built. So Inception was built, as we said, initially collaboratively with Target. And what we wanted to do was understand where the people were engaging as they were coming up to the environment, to the fixture, to whatever that was. So we were able to define different zones of interactivity. Based on what they're doing, we're delivering content, pulling that from Azure, and then streaming the telemetry live into the cloud so that we can gain insight into what's happening. And then ultimately learn and react to things that might be going out of band. People are hanging out. They're looking puzzled. Can we reach out and help them? Those are the kinds of things that we wanted to do. And what you see there also from the Connect sensor is a tie over to NEC. After we got done working with Target, NEC approached us and said, you know what? We can do even more cool things if we combine your Connect sensor with our anonymous biometric services to be able to understand age and gender. And then even in secure scenarios, be able to understand who the user is individually. There's some really interesting interactions that you can start to drive that way. So ultimately,
I mean, we can at this point perhaps draw a line to the howold.net that we saw this morning, and that went, by the way, ballistically viral on Twitter right now.
Right.
But it is still very interesting to see what we're seeing here is even a step beyond that. You're not submitting a photo and you're waiting a second or something. This is all happening right there.
Right there in real time. That, reaching out to the cloud to perform that function, while interesting, when you're trying to interact with somebody that's present right now, that delay could cause a problem. So leveraging NEC's sort of industrial service on the client within 1/10 of a second to get that information is a whole lot more reactive experience than waiting. I mean, hopefully the cloud is fast, but God knows what's happening, and it could be 2 minutes and suddenly they left, all right? So now all of it is foundationally built on top of the Microsoft stack, from the Connect sensor right through to the code that's executing on the device. It's all C# code. Ultimately delivering that up to Azure, the Event Hub being processed through ASA, then ultimately into Hive, and then to a big data cluster, and then ultimately could be fed into machine learning. And then ultimately we can party on that data in Excel. And that's cool, but too much talk. Go to the next slide. So Inception is really, again, I mentioned it's about transparent computing. It's about a collaboration. That's one of the things that the technology centers do, is we like to do the hard stuff. Come to us and say, we want this magical thing. We're like, yeah, game on, let's try that. Having partners like NEC who stepped up and went, yeah, let's try this, and started to build their tools and extend their tools in such a way that we could consume them in new and interesting ways. And then finally, what really blew the doors off of Target was the fact that we did it in 3 weeks. 3 weeks. They were like, wow, that is ridiculously fast. And it's a case of, you know what? When you know your kung fu, all right, you can really execute. Having the cloud as the backbone and the sensors. All right, so let's do a demonstration.
So you had Connect sensors flying all over the room?
Oh, absolutely. We had Connect sensors flying. We had, it talks, it walks, it does amazing things. So what you see up there is the kiosk that is actually here that was live in the store. But if I can get it switched over to the, which one is this? Five. All right. So groovy. What I am going to do here is I can actually run code if you really want to go to code. But I think what we'll do is I'm going to go ahead and run the Inception executable here. And all right, awesome. Hey, is that a compelling user experience or what? Okay, man, that is awesome. All right, shoppers just gravitate to that kind of experience. No, what you're seeing here is the experience understands not only people. Everybody knows that Connect can track and I can play games and stuff. But what they don't realize is that we can teach it to understand objects in a physical space. This is the calibration window that we use to actually teach it where objects are in a physical space. I just thought it was geeky fun to show it off. The black thing that you're seeing, the black screen on the far right-hand side of the display is actually showing where the physical item is in three-dimensional space. So you can think the Connect sensor is at the top of the screen, and you're seeing my body here as this flat line. And if I move my hands, see how my hands are out there? That's actually showing the depth range to my hands. But we're not going to calibrate. We're just going to go in and try some stuff. So remember I talked to you about having it have the ability to understand when somebody is in a certain space, right? So there's different ranges that it interacts with. I've defined 4 for this case. It doesn't need 4. It could have 1. So passive engage, it's delivering some content. I come in closer. It goes into active attract. This content could be whatever you wanted it to be. Now at this point, the NEC tools are biometrically sampling my face, doing an age and gender analysis to additionally target content if we wanted to. Now if I walk up even further, they think I'm starting to play with it. And then when I walk up on top of it, I'm in active engage mode, which means it's assuming I'm up here picking up things, I'm playing with stuff, and it wants to help, ergo the high piece, all right? So right now, it's monitoring and it's watching what I'm doing. Now what's fun is this is only half the show. If I flip over here to Azure, I'm in the stream, one of the stream analytics pipelines that we use. This is a relatively stripped down query that we're using. So one of the things that you might want to do is, hey, I think I mentioned the fact that somebody might be shopping too long or is hanging out or looks like puzzled, right? Well, this is an interesting tumbling time window query that is actually looking at the tracking data that we are sending from Connect. We are sending every frame, every every third frame from connect up to the Azure cloud, so that we can tell you in three-dimensional space what was happening. I can have services like ASA monitor those things and understand that, wow, there seems to be something going amiss. Let me send a push notification to you. And in a few moments here, I'll cross that threshold, and an app on my band will buzz me and say, somebody needs help at the kiosk. Do you want to go over and talk to them? That's cool, right? Okay, now, we have got all of that. Now, what's even more fun is let's go party on some data. All right, so we've got a variety. Oh, here, I got to go to that spreadsheet. This one's more fun. Let me go here. There we go, beer. Okay, beer. So this one is fun because guess what? We used Inception at the Super Bowl. It managed a bar. Come on, that's cool, right? So it actually watched beer bottles, and it went, oh, you're getting a shock top. Oh, you're getting a Grey Goose, or whatever that is, or a Bud Light. And it's keeping statistics over time. And I've got this beautiful Power BI that allows me to look at, hey, there's a lot of old people. Sorry, did I say that? I'm sorry, I'm in that age group too. Anyway, and what beverage were they selecting?
Well-aged people.
Well-aged, absolutely, absolutely. Experienced folks, all right? And you might go, why at the Super Bowl, at the bar, were the people skewed towards the 50, 60 age bracket? Well, it was because the bar was the VIP bar for all the distributors, all right? So you can imagine they are a little more seasoned than the average visitor. So that's kind of fun. So I can actually see which beer they selected. Oh, by the way, one of the fun things we did with them is NEC also gave us access to their face recognition API. Now, we didn't know anybody, and the API doesn't know anybody. All they wanted, though, was Anheuser wanted us to be able to do a personalized greeting. So basically, when you walk up and you pick up a shock top and then leave and then come back an hour later, the sign says, hey, another shock top. All right. Hey, Tony Stark, right, man? Totally? Okay, now let's go look at some other things. All right, that one, we already looked at that one. Let's look at this one. So here's telemetry trends over time. So I don't have as beautiful reports as my friends at Fujitsu, man. I got to get their graphic designer. But here I'm actually playing back over time where people were in three-dimensional space. That's really quick to show you, but the numbers on the vertical are meters away from the sensor, and the bottom numbers are indicating left and right in front of the device. And this is sort of an average over time where they were orbiting in relative position to the sensor. Now, if you think that's cool, wait until you see, I got a couple other reports to show you. Now, here we take the biometric data that NEC gave us, and we start to party on that. And we get to see by day part, by time, which different gender, age populations were actually interacting with the environment. And then ultimately, they do some interesting standard deviation stuff, min and max calculations. That's all kind of cool. Now, the one that I think is the coolest visualization we have, and I have to admit, it is a bit of a moonshot, because I have yet to see anybody do it. And of course, come on, big fella, you can do this. I know you can. Don't embarrass me now. Come on. I was going so well. Let's go here. Come on, come on, come on. Oh, great, googly moogly. That is not happiness. Well, so I'm going to use the theater of the imagination here. All right. After this, if you come talk to me, I'll show you the report. All right. What I was doing is, any of you seen Power Map before in Excel? Power Map, right? We all see Power Map. What does Power Map do? Does geo mapping of telemetry data, right? I get to see sales in different regions, all that kind of stuff. I bet you've never seen a Power Map that's down to like half a meter. I can actually play back, and you can see people moving through the space in front of the actual fixture. I can see heat maps of what product they're touching. That is cool, all right? That is cool. Now,
especially if you're in retail.
Yeah, oh, absolutely, absolutely, absolutely. Well, it's cool nonetheless.
It is
all
cool.
Right, it is cool nonetheless. Now, so we're collecting all this, we're capturing all this, we're all punching it up into Azure, and this is really cool and it's fun. Now, if we flip back to the slides here, let's go to the next slide. So what I want to do is introduce you to the Inception framework. We have been working on this code for about 9 months, evolving it as it goes forward. And within the next month, we will be releasing a reference app that allows you to build solutions like this, using a Connect sensor and all the Azure plumbing. We will ship to you a Connect telemetry capture routine that knows how to talk to Connect and deliver the telemetry efficiently. The NEC plugin that allows us to augment and extend that data from the Connect sensor. The Azure scripts, by the way, that Azure Power script right there is well worth the price of admission by itself, all right? That bad boy is about 150 beautiful lines of PowerShell, all right? That automates everything. Just give us a subscription number and we're off. We'll give you a kiosk reference app that will allow you to do some of these basic interactions and off you go. We will give you a biometric and face recognition app. What that is all about is the ability to understand how we're doing the biometric and face so that you could say, you know what, I don't want your kiosk thing, man. I want to do something cooler with it. Let me just see how you made that all happen. And then ultimately, we're going to give you our basic object detection code so that you can understand when people are grabbing and touching objects in a physical space. That's cool, right? Oh, good gravy. All right, let's go to the next slide. So, go-dos. Inception in combination with Windows 10 will let you do amazing things. Now, why do I mention Windows 10? I was running Inception on Windows 8 here. Windows 10 gives me an entirely new pivot because I now have a computer framework that sees, understands where you are, who you are. I can do voice recognition on Windows 8, but it's dictation engine if you're of that persuasion. I want to do keyword spotting. I want to do continuous recognition. If I'm in a space, I want it to recognize me, and I want it to understand Todd is an expert in all things Connect. If Todd starts talking Connect, I want it to go retrieve information for me. Windows 10 gives me that extensibility that I need to deliver that pivot on the foundation. Ultimately, sign up for Inception. Stop by the Connect booth out here. I'll be hanging out. Give me cards. I'll get you on the line. When we formally release it, it'll be on the Connect blog to let you know when to get it. And then ultimately, guys, go do cool and amazing things. That's what I got.
Thank you very much, Todd.
Thank you.
Thank you.
Nice job, man.
All right, so we saw a little bit of a rainbow of scenarios. And to me, the important part is that all of those directly connect to scenarios that we're seeing, real companies having real problems that want to be solved. So that's one important reason that we put half of our time in that basket, and I hope you enjoyed that. So now we would like to go and zoom in a little bit on Stream Analytics and tell you some more about that. And what we, as kind of an approach, we can go and say, among all those scenarios, we are seeing effectively 3. There are a few more, but right now we're kind of focusing on 3 classes of scenarios. The first one is you want to capture streaming events as they come in, perhaps do some level of immediate cleansing, filtering, correlation with reference data, whatnot, and archive. So that you can then later go and do after-the-fact analysis. Right, so one example we saw of that was after the fact, I would like to understand how plant production evolved over 6 months. Second one, dashboarding. I want to go and see in many different ways what's happening right now. Not just at the level of raw events, but at the level of meaningful roll-ups of that. I want to see various forms of aggregation over my data as it happens. And the third one is I want to actually cause activity or action to happen if certain conditions are met. I want to trigger workflows. Aerocrine may want to go and trigger the automatic shipping of new sensors to their customers. Very much now being in the same business as inkjet printer companies, except that a small company like Aerocrine would never have been able to do that on their own, deploying data centers around the globe, building the logistics connections, and so on. So the way we typically build those solutions is very kind of canonical. And we actually saw in both of our guest presentations essentially this pattern here, where we start with a form of raw data coming in, getting collected, sometimes through gateways, sometimes coming directly from the device, typically going through event hubs. Event hubs having this interesting property that it retains incoming data for a short window. Like typically a day, you can pay for more. But every event hub will keep data at least for a day, which means that everything composed downstream from there, including stream analytics, has an opportunity to recover from all sorts of failures by simply quickly going back in time and replaying. The next step, typically, if you want to go down the real-time as it happens path, is that you use stream analytics or other stream processing solutions that pull from Event Hub, apply immediate processing, and push the results forward. One thing that we saw repeatedly is pushing forward into dashboards like PowerBI. We have a number of those cases. We'll see another example of that a little later. Another thing that we are only announcing today is, and we'll see more details about that later, is that we are now integrating stream analytics and AzureML, which will allow you to, on the fly, as it happens, apply various interesting algorithms, if you like, to the data that flies through the stream processor. So if you want to see what stream analytics brings in terms of advantages, because, you know, to be fair, there's a rich spectrum of stream processing technologies out there, right? Many of them are in the space of fully general programming frameworks. There's like Storm, Spark Streaming, many of them. And many of them run today on Azure. So you have the choice. So we want to go over what are the kind of hard facts that differentiate stream analytics from other solutions, not in the sense of this is better than that, but in the sense of if you have to make that choice, here is how you can think about that. So the first one is, if you build, and this is actually a very real experience we have had with our many sort of partners we're working with, you're building a stream analytics solution, you have a here and now need that is often surprisingly low. We scale down to 1 megabyte a second and make you pay for only that, because it turns out that is 86.4 gigabytes a day. That actually is, for many, many solutions, plenty. But of course, you can and want to have both the ambition and the reality of scaling way up. And so we want to scale your solutions up to the gigabyte a second range. We want to process at low latency. We are not actually processing at kind of hard real-time latencies. So we typically aim for kind of a single-digit seconds. But the system is built to adapt automatically if you're actually, relative to the resources you're paying for, sending a relatively low rate of events, then we'll automatically give you much better latency. Okay. So the system smartly adapts to load. The next kind of differentiating property is that it is very capable of correlating both between streams of data, even correlating, and we'll see examples of that, correlating events on a single stream of data by asking for happens before, happens after kind of scenarios. But it also can correlate with reference data. And we'll talk about that a little bit later. Ultimately, it's a fully managed Azure service, so you get all the advantages of that. That is just kind of comes with the deal of Azure services. Likewise, in the space of reliability, we guarantee event delivery, and we guarantee business continuity. Both things that if you build on lower level infrastructure are actually very expensive for you to maintain yourselves. Interesting property, we support effective audits. If for your own solution, you need to be able to demonstrate security or privacy properties to your auditor, then having a piece in the middle that is very high level makes it almost a self-evident situation. You select away personally identifying data, it is gone. There's no way that someone can sneak some code somewhere into the solution that brings it back. Right? So having the ability to audit for critical properties of the system is actually a key thing in more and more industries these days. And we talked about scale already. And finally, let me not spend time on this right here. We have done quite a bit of work to make sure that you can very rapidly build your solutions by focusing on the actual problem you're trying to solve instead of a lot of infrastructure aspects. So historically, you would have gone and said, I need to sort of procure and set up infrastructure. This may be as simple as getting some VMs in the cloud. You need to code your solution. You need to go and integrate with a lot of other things. You need to manage the resiliency of your solution. You need to go and worry about scaling. And ultimately, you need to monitor and troubleshoot your solution. So our aim is to take most of that out of your hands, do it for you, and allow you to focus on what you really want to do, rather than this traditional stack of stuff that you would also have to do. All right, here's just a very quick look. The Stream Analytics query language is a fair subset of T-SQL, enriched with a few temporal concepts. And that's actually very important. If you think about the operators in SQL, then almost all of them have this problem that I mentioned in the very beginning when you count red cars on the highway. Almost all of them would never give you an answer on an infinite stream. So the temporal extensions are absolutely vital to make this kind of language work. So at this point, I hand back to Dipanjan.
Thank you, Clemens. So we have heard enough about this product. We have seen a lot of examples. Now let's get a little deeper into the language and see how you can do things and what it provides. So let's take this scenario. Let's say a media website company, they want to increase traffic to their website, and they are trying to look for trends, tapping into social media. They want to look for what are the trending topics, which topics are being more discussed, and based on that, take decisions, right? So here is, we're tapping into a live Twitter stream, and the payload looks something like this. We have a timestamp, we have the user who is tweeting, the text what they're tweeting, time zones, etc. Now, if I have this Twitter stream and I want to say that show me the username and the time zone of a particular topic, say Xbox, how would I write that? Now consider here, the stream is moving towards the right, the time flows towards the right, and we are all familiar with our SQL statements. It is just as simple as you had been using it. So I use a select here, I use the username, the time zone from the incoming stream, and where topic equals to Xbox, right? Now let's see how that would look like. If I want to really experience this in the Azure portal, let's see how that would look like. Let's switch. Okay, so I'm in the Azure portal right now, and let me quickly go and create a job. And we can see here under data services, you see stream analytics. I'll use quick create and say my build job. And I can select the region here where I wanted to create. I selected US Central. And now what it is doing is it's trying to create a shell for me. So the job shell has been created, but that has nothing yet. And having a job operational really is a matter of few steps. So the first thing you do is you have to add input, meaning describing where the data is coming from. So let's say I go and add an input. We support data streams and reference data. Clemens will talk about that a little later. So I select data streams, and let's say my data is coming from Event Hub. I give a name here, input stream, and this is the name how you refer it in the query. I could actually map it to something that exists in my subscription, and it will pull all the details for me. You can see it has an event hub here. I selected the namespace of service bus, and it shows me which event hub it is. I go to next, and I can select what serialization format my data is coming. In this case, it's JSON format. I say, OK. Now it has added that, and it's also doing a sanity check whether this particular source is available or not. Even if it's not, then it will still allow you to go ahead and create the job. you need to make sure that at runtime, this source is available. So I have got my input created. I go to output, and I can add another output to that. These are the outputs that we support. Power BI is now in preview, so let's try that out. So I can go to Power BI. First thing it will ask you is to authorize. Once you get authorized, you can go ahead and give it a name. So I named it output, my data set, and a table name, table. And I have my input created. I have my output created. Now the next thing is I have to go and write my query. So let's take the example that we just saw. I'll go ahead in the PowerPoint slide deck and just copy that query and then put it here. Now, normally, a good developer experience is you want to validate how your query, the query that you have written, whether it is correct or not. Normally, in a streaming data, it's very difficult because you have tons of data flowing at you, and you're running your query. Whatever you are seeing in the output may be right or maybe not. How do you make sure that you have written the correct query and make changes according to your need? A good way would be to take a sample data and test over that. So we have a test button here that allows you to map it to a local file. So you can actually grab data from your incoming sources there, and then map it to a file here. I have some data collected, and I do that, and I run the query against that, and I can see the results right there in my browser. If I want to make changes, for example, let me add the timestamp here and just do a rerun. And now I have the timestamp also coming up. So this allows me a nice way to see what the results are and give me the opportunity to make changes. And then I can deploy the job. So let's switch back. OK, so that was good. Now let's look at some more examples. Windowing is a very common concept for streaming. So you want to ask questions, not like select star of everything. That was good for the database world. But now select star of everything means you have to define what that everything means, and that should be within a window. As Clemens was saying, if cars are moving over a highway, then you may say, give me the count of cars over the last 1 hour or 5 minutes or 1 minute. So we support 3 kinds of windows: tumbling window, hopping window, and sliding window. All windows are fixed length, and they are supported by the group by clause. Now, in this example, you can see window 1 has a few events that fall within its space. If I want to do aggregations like sum or count, the result would be shown at the end of the window. And all events in Stream Analytics has a timestamp associated with it. So the output that we see will also have a timestamp, but it will be aligned to the end of the window. And yeah, so let's take this example of a hopping window. A hopping window is, I may want to define, like, give me a count within a 10-second time frame. Now, I may want to see results more quickly. I may want to see results every 1 second or every 5 seconds. Show me the result of the last 10 seconds. So here's an example. If I want to give me what is the count of tweets over the last 10 seconds, how do I write that query? It's very simple, but I want it to be updated every 5 seconds. So you just use a function called hopping window, give it a parameter, pass parameters 10 and 5, and there you go. Now imagine if you had to write such code, it would be tough because you had to do state management and various other things to make sure you're doing the right thing. Another useful thing is, how do I correlate data together? Let's take this example. I have the Twitter stream coming in, and the second one in the green is the same stream, but it's forward in time. If I want to see all the users of a particular topic, they're tweeting on a particular topic, if they have switched their sentiment within 1 minute, these are some kind of pattern analysis that you're trying to do. How do I write that? If you look at that query, I have a from Twitter stream, which is my first stream, and then join it to the same stream. I'm doing a kind of a self-join there, and I am joining on. Now, every join needs to have a condition, right? So here my condition is the user needs to be same, and the topic needs to be same. So the same user is tweeting on the same topic, but the sentiment has changed. So that I have in the where clause. if the sentiment of the first one is not equal to the sentiment of the second one. But there is one thing interesting to observe. Normally in SQL, just that kind of join condition will work. But this is streaming, so there has to be a bound, a time bound. This join condition is valid between 1 minute. That's what I want the results for. So if I run this query, I will see the green ones, the pairs would be coming in my output, but the red one certainly meets the join condition, but the difference of time is more than 1 minute, so that doesn't come. So the correlation of time automatically happens. Another interesting thing is to detect absence of something. How do I do that? For example, if I want to find out if a particular topic was not being tweeted for the last 10 seconds, how do I do that? It's very simple. I use a left outer join. And on my right stream, I compare it to null. So these are very well-known tactics, and you can apply your same skills in the stream analytics query language and build different patterns very easily. OK. So that's the one thing that gets left out, because that was not tweeted again. So you want to talk about the reference data? Let me switch over to Clemens.
Sure. And I think we'll go a little faster now because we're approaching the end of our session time. So I already mentioned that besides joining between streams, we can join with reference data. There's a little sort of trick to that, and that is understanding that the stream analytics engine at runtime can time travel forwards and backwards, both to meet join requests, like join Twitter now with Twitter at some earlier point in time, or to recover from internal failures. And therefore, we cannot actually use a typical mutable store, like a database, for reference data. So instead, we draw on reference data out of blob store, but do support the notion that you periodically push updated reference data into blob store with a timestamp. And so we can then go and say which of those snapshots we should use when joining against reference data. That is actually a very powerful technique in the IoT space, because most devices send you some cryptic IDs that aren't suitable for further processing. Instead, you want to join them, you get a device ID, you want to join it against a device logical name, you get an IP address, you want to join it against a geolocation, and so on. All right, very quickly on this one. The entire stream analytics engine is built to have absolutely zero centralized state or centralized coordination. It's a fully distributed execution framework. And that means if you only give us enough information about how your data is partitioned and how your query naturally partitions, we can give you whatever scale our underlying hardware can give you. Okay. And so the trick here really is to just tell us that a particular stream is partitioned. By the way, all data coming from Event Hub, if you use Event Hub in a normal form, is already partitioned by the partitions or shards of the Event Hub. So there's your first opportunity. And then you can ask us to repartition your data for various purposes, or you can do MapReduce style things by first doing in parallel operations over the partitions and then reducing to a global result. So here's an example of a more complex query that uses a number of these techniques. It uses the SQL concept of common table expressions. In functional languages, people call that a let lift. So these with expressions are basically having subqueries. We interpret top-level with as you telling us that there's a natural step nature to your query. And if appropriate, we use that to build a pipeline at evaluation time instead of running everything on a single node. So we do scale up, scale out, and pipelining, three-dimensional optimization for your queries. OK. Then the one thing I definitely want to make sure we squeeze in today,
Yep.
I already mentioned it briefly. As of today, we are in a limited preview with our ML integration. And so if you're interested in that, our team blog, it's not quite up yet, So perhaps check tomorrow. Our team log will have information about how to sign up for that limited preview. And we ask for a description of the scenario you have in mind, because we want to actually go with the selected initial partners in that preview and really understand what works, what doesn't work, what's missing. So that's this, and the model for that is extremely simple. Here is the case where you want to apply a function, really, a user-defined function, to every point, every data point on a stream. And you may have noticed Stream Analytics itself doesn't have any user-defined functions, at least today, and you would say, oh my God, that's a huge blunder. The ML integration backfills that because in the end, AzureML can run arbitrary code today in R or Python, in the future in other languages. And so you just bind an arbitrary REST endpoint that has the right kind of protocol support to a function name, and in this case, it happens to be an operationalized ML model. And we do have a demo for this.
Yep.
So switch back to.
Yeah, let's switch back.
And after that, we'll close the session. I'll just give you a little bit of detail on the pricing of Stream Analytics as a service.
So here we have a Power BI dashboard, and we can see the trend here, the count of tweets by topic. I am looking for some interesting topics like Azure, Microsoft, Seattle, and various other things. On my right, I can see what are the texts that are coming in, some cool things like how many total count of tweets, and I can also see the sentiments along with each text. So let's take a look at how this is possible, what's going on behind the scene. So let me switch to the job. So here's the job that is running, and where you see that dashboard, I am making a call called sentiment, which is a function that I've defined. This is pointing to an ML model, as Clement says, and that's all you do. So for every event that comes in, here I'm calling a sentiment model. You can use anomaly detection or any other thing that is supported in machine learning and make calls to that. So this also shows how you can take the output of one subquery, push it to a particular output source, and take the rest of them and push to a different one, or support basically multiple outputs. Here is how the monitoring dashboard will look like, and I can see how many events are flowing in, what is the kind of output I'll be seeing, whether there were any runtime error or not. So this gives me a very nice view of what's going on with my system. All right, switch back.
And as I said, the one thing I want to quickly talk about is pricing. We found out that there are really two reasons that good pricing of that particular service is relevant. One is that some people care about massive scale-up. But what we have actually found far more people care about is running a potentially very large number of such streaming jobs in their larger complex environment. And so we drove this price quite way down. To give you an idea, we're measuring two things. One is the actual volume of data processed at 1/10 of a cent per gigabyte processed. And the other one is a blended unit of effectively compute resources, cores, memory, and bandwidth at 3.1 cents per hour. Okay, and that translates into the smallest single streaming unit job running nonstop, costing you just a little under $25 a month.
That's dirt cheap.
Right, and that basically, you will actually find it to be really difficult to pay for VM resources yourself to get anywhere close to that price. And we do a little more than just give you VMs. Okay, so that's the pricing. I think we don't actually have official time for questions, but I would still like you to take the opportunity if you have questions. There are some microphones here. And also, do this one.
Yes.
Thank you.
All right, thank you.
Thank you.